allied technologies. In the previous video, we have learned about what is a programming language, what is a program, need of programming language, and the history of C programming language, what is high-level programming language, low-level programming language and all. But today, in the series of video, we will be discussing a very new topic, that is a language translator. What is this language translator, or what is the need of language translators? How many language translators do we have? What is this assembler? What is the difference between the compiler and the interpreter? These are the set of questions that one will definitely have. So let us discuss with the concept. As discussed earlier, the only language the computer can understand is the binary language. For an example, if you write any code by using the binary languages, the computer will definitely understand, which is absolutely fine for us. For example, if you write any code by using the high-level programming languages like C, C++ and all, the computer will definitely not understand. Why? We have discussed in the previous video that the computer will not understand all the English words or phrases and all. So in order to make your computer understand, what we have to do is, we have to convert the source code into the object code, that is the program into the object code, that is to the binary languages, which will be in the form of zeros and ones. This kind of translation is done by the language translators. So now let us put it into a proper definition. What is language translator? A language translator is a program which is used to translate the instructions that is written in the source code to the object code, or to convert or to translate the high-level programming language into the machine-level programming language. So this is what is language translator, or what is the need of language translator. So guys, we have three types of language translators. The first one is the assembler, compiler and the interpreter. So these language translators are used to convert the source code to the object code. What does this assembler do? This assembler converts the assembly language programs into the object code, that is to the binary languages. For example, if you write any program by using the assembly languages like C, C++, Java, Python and all, these programs are converted to the object code by using the translator, that is by using the language translator assembler. And we also have this compiler and interpreter. What is this compiler and what is this interpreter? So this compiler and interpreter are the language translators which is used to convert the high-level languages into the machine languages, that is the source code, into the object code. How does it convert, or how does this compiler and interpreter work? Let us see how it works. So guys, now let us see the working of this compiler and interpreter. For example, if you write any program by using the C programming language, once after the program is written, it must be compiled and interpreted, and then we'll get the output. In the same way, we have two language translators that are used to convert the source code into the object code. What does this compiler do, or how does this interpreter work? Let us see now. So a programmer will write the set of instructions or set of sequence of lines of code in the form that will be called as source code. So this source code is read by the compiler at one time and gives the object code. And what does this interpreter do? This interpreter reads the lines of instructions line by line, convert it into the intermediate code and gives you out the output. So we can tell that compiler converts before execution and interpreter converts while the program is executing. And the second point is translation happens before the execution, whereas in the interpreter, translation and execution is happening parallelly. How can we tell that translation and execution is happening parallelly? See, when you have written lines of code or sequence of lines of instructions, so first line of code is taken and it is then translated and given as the output. If any error is noticed, then this interpreter will stop the execution. So we can tell the translation and execution both are happening parallelly in interpreter, whereas in compiler the translation happened before the execution. The third point is the object code is created in the compiler, whereas in the interpreter there is no object code created. We can tell that source code is converted into object code in the compiler, whereas in the interpreter, it will read line by line, translation will happen, and then the execution will happen and gives you out the output. There will be no source code or object code will be created in this interpreter. And coming to the fourth one, less time taken is less in compiler and the time taken is more in the interpreter. Why this time taken is less in compiler and time taken is more in interpreter is because this compiler, as I told you, it will read whole set of instructions and gives you out the object code. So the time taken during this translation is very less. Whereas in this interpreter, I told you that it will read line by line and it will translate and gives you the input. So this will happen for many times. So the time taken by the interpreter will be more. And fifth point is debugging is very tough in the compiler and debugging is easy in the interpreter. Why is this? Because in this compiler, the program will be read at once and it is compiled and then the object code is given, and if there is any error in the set of instructions or set of program, then it will be listed. So it will be very tough for us to identify in which line the error is and all. But in this interpreter, as soon as you get an error in the second line or third line, the whole execution stops. So the debugging is quite easy in the interpreter. Coming to the last point, that is memory space, there will be more memory space and less memory space in the interpreter. The consumption of memory space is more in compiler, whereas the consumption of memory space is very less in the interpreter. This is why, because here in the compiler an object code is created and this object code must be stored in memory. So the more memory space is needed because all this, the object code is a huge thing which need to be stored. Whereas this in interpreter, less memory space is needed because we will be not having any object code or any such object things generated. Only the direct output it fetched up. So there is no need of memory space. Less memory space is required in the interpreter. So guys, now let us briefly describe the difference between the compiler and the interpreter. So the very first point is compiler converts before execution of the program, whereas the interpreter converts while the program is executing. The second point is translation happens before the execution in the compiler, whereas translation and execution is happening parallelly in the interpreter. The third point is object code is created in the compiler, whereas there is no object code created in the interpreter. The time taken is less in the compiler, whereas the time taken is more in the interpreter. Debugging is tough in the compiler, whereas the debugging is easy in the interpreter. Compiler needs more memory space since the object code is stored in the compiler. So the less memory space is required in the interpreter. This is very important that C, C++, C# are the compiled languages, whereas Python, Ruby, Perl are the interpreted languages. So guys, I hope today's topic was very interesting and we discussed about what is language translator, need of language translators, difference between this compiler and interpreter and all. Please subscribe to our